So we're continuing our circles chapter with doing area of a sector of a circle. Once again, sector of a circle is what's known like a traditional pizza slice, the region between two radii and an arc of a circle. This is the area, this is a sector, so I'm trying to find a formula for the area of a sector, okay? It's very similar to the formula for arc length with one little exception. So let's quickly review the formula for arc length. If I wanted to find the length of this arc BD, if you remember, to find the length of the arc, which I like to abbreviate like this, some people don't like that, but that's my style. Okay, the length of the arc was thought to be as a fraction of the circumference of the circle. And the way we got that fraction, it was the measure of the arc over 360 times the formula for circumference. This is what we use to get the length of an arc. Well, to get the area of an arc, it would be the same thing. Okay, only it's not a fraction. By the way, let's call this sector BCD. Some people think of it as a fraction. It is a fraction. I still want you to consider it that way, a fraction. But it's not a fraction of the outside. It's a fraction of the inside. It's a fraction of the area of the circle. Okay, so the fraction, you'd get it the same way you got the fraction before. The measure, the arc measure over 360, that's how you would get the fraction, and then multiply by not the circumference formula, but by the area formula for a circle, which is pi r squared. And this is the formula we're going to be using to get the area of a sector. Okay, so let's go ahead and do some practice problems. So let's do, say, this one. If I ask you to get the area of this sector in red, it's going to be the measure. Oops, I forgot to give you the measure. My apologies. Okay, so it's going to be the measure over 360 multiplied by pi times radius squared. Again, always write the formula first. The measure over 360 pi times radius squared. I like to reduce, as you know, 120 over 360 reduces to 1/3. This is 1/3 of the circle. Okay, but I don't want the whole circle. I only want a portion of it. The entire circle is 81 pi for its area. I want 1/3 of that. So 27 pi square inches would be the exact area of that sector. And if you go ahead and you use the pi key on your calculator, that would be approximately 84.8 square inches. That would be the area of that sector. Okay. Now I'd like for you to try two on your own. Okay. Say, look at these over here. These are the same problems we had earlier, the same circles that we had earlier for arc length, but this time I want you to do the area of the sector. So I'll do them both, but you can pause them and do them on your own. You'll see the answers as soon as you replay. So to get the area of this red sector, it's kind of darkened. I'm not sure if you can see that on the screen. So I just went over it in red. To get the area of this sector, again, the area formula for a sector would be the measure of the arc over 360 pi times radius squared. So in this case, the measure of the arc is 135 over 360 pi times 12 squared. Now 144 pi would be the entire area. I don't want the entire area. I want this fraction of it. So what would that fraction be if you reduce it? I know some of you hate to reduce, but it just makes it so much easier, especially if you're not going to have a calculator with you. But this reduces to 3/8. This reduces to 3/8. You could divide top and bottom by 45 if you use the greatest common factor. And then 144 divides by 8 nicely. 8 divided by 8 is 1. 144 divided by 8 is 18. So this comes out to 3 times 18 times pi. which is 54 pi square meters. That is the exact answer. And if you had used the pi key instead, it would have been about 169.6 square meters. Okay, try the next one. I'm going to do it now, so you might want to pause it and see if you get the same answer. Okay, so for the next one, it's going to be the same thing. The area of the sector would be the fraction. In this case, the fraction is the measure is 240 over 360. So it's going to reduce to 2/3. And then times the area of the circle. Now the radius is 16. So 16 squared is 256. So 256 pi. That's the whole circle. Now I don't want the whole circle. I only want 2/3 of it. Now this does not divide nicely. And I purposely chose that because I don't want you to think it's always going to divide nicely. So if it doesn't divide nicely, if I can't divide, if 256 is not divisible by that denominator, in this case 3, just multiply horizontally. And you're going to be left with 512 pi on top and 3 on the bottom. So this is the exact answer, 512/3 pi, or 512 pi divided by 3. Now for the approximate answer, multiply 512 times pi, and then divide that by 3, and it's about 536.2 square centimeters if I round to the nearest tenth. Okay, now you might think, where am I ever going to have to use this? Oh my gosh, this is so boring. I'm never going to use this. And in fact, this is probably one of the things you're going to use the most, okay? What's this? Anybody know? This is a floodlight, okay? You probably have them in your house. It looks something like that. Even a camera, if you have them in the outside of your house, okay? And these things are a perfect real-world example of area of a sector. So when you buy these items, it'll tell you on the package several things. It'll tell you on the package the measure of the central angle of the arc that it corresponds to, of the sector that it corresponds to, and the distance that it picks up any movement. This part right here, oops, let me go back. This part right here is a motion sensor. So it picks up movement up to a certain distance. Okay, but of course that distance is not infinite, it's a set amount. Now, if you're thinking, oh, that's not true, I've never seen that. It just so happens that I happen to have a motion sensor box here. See, this is a motion sensor light. It doesn't have the bulbs, but this is the item, see? Okay, now on the box, here it is, brought from Home Depot, purchased from Home Depot. If you look at the box right here, it tells you the measure of the arc. See, that looks like a sector, doesn't it? It tells you the measure. And then on here somewhere, sometimes you got to look for it, it tells you how far away it can sense movement. So here's the side of the box. 110 degrees is what? The measure of the arc. And 70 feet right there, it's a little bit out of focus, that is the radius. Okay, so we're going to figure out what the area of that sector that this thing can sense movement in. Okay, got it? Okay, so let's begin. Let's go back over here. Okay, so this is not the same one, but it's similar. So the one that we had a second ago, remember that we said it's a sector, drawn really badly, but the measure here is 110 degrees and the radius is 70 feet. So to find the area of the sector, 110 divided by 360 times pi times radius squared. Now 110 over 360 reduces to 11/36, and then this would be 4,900 pi. Let's go ahead and get the approximate answer to figure out approximately how many square feet is sensed by this sensor. So we'd do 4,900 times pi times 11 divided by 36, and you'd get approximately 4,700 and 3.7 square feet that this sensor senses. That would be the area of this region. Got it? And cameras work the same way. Cameras sense movement in a certain angle, certain range. Of course, the more expensive ones have a bigger angle and a bigger range. Okay, hopefully you've enjoyed this lesson on the area of a sector.